content is for educational purposes only, drawing from our professional and educational experiences and opinions. Please use this information at your own personal or professional discretion. We are not liable for anything you do with this information.
Good evening. Welcome to Ask the Lady Electrical Inspector podcast. I am your host, Tabatha L. In tonight's episode, we will explore one of the most common reasons electrical installations fail inspections when using NEMA 3R enclosures. During inspections, one significant issue that repeatedly appears is the installation of unlisted connectors and fittings that do not meet UL standards. In wet locations, raceways or cable entries situated above the level of uninsulated live parts must use UL listed fittings specifically rated for wet locations to prevent moisture entry. When fittings are not properly listed for this application, they can compromise both the safety and code compliance. Many failures occur because installers do not follow listing requirements or NEC rules for wet locations. Tonight, we will review several key installation considerations for NEMA 3R enclosures, including watertight fittings, location constraints for conduit entries, proper sealing and of openings, and why top entries should generally be avoided. We will also discuss the only listed connector approved for conduit entry above uninsulated live parts in a NEMA 3R enclosure, the Myers Hub. Let's start with understanding NEMA's ratings. Before we get into the inspection failures, it is helpful to understand why NEMA 3R enclosures are commonly used in outdoor electrical installations. One widely adopted enclosure standard is the NEMA rating system, established by the National Electrical Manufacturers Association. The National Electrical Manufacturer Association, NEMA, rating system has been a fundamental standard in the electrical industry since its inception in 1926. It was created following the merger of the Associated Manufacturers of Electrical Supplies and the Electric Power Club, with the primary objective of establishing uniform guidelines for electrical equipment and specifications. A critical aspect of this initiative was to clearly define the environmental protection capabilities of electrical enclosures, such as resistance to dust, water, and corrosion, thereby ensuring safety, durability, and reliable performance across diverse applications and environmental conditions. NEMA rating classify enclosures according to the level of protection they provide against environmental conditions such as dust, rain, snow, ice, corrosion, and physical impacts. A NEMA 3R enclosure is designed for outdoor use and provides protection against falling rain, sleet and snow, and external ice formation. A key requirement in the NEMA 3R definition is that the enclosure must not be damaged by the formation of ice on the exterior surface. The intent of a NEMA 3R enclosure is not to make the enclosure waterproof, but to prevent water from reaching energized components. Any incidental moisture that enters the enclosure is expected to drain away through the weep holes or the drainage openings located at the lowest point of the enclosure. Common applications include utility meter sockets. Most electrical meters mounted on building exteriors or installed in a NEMA 3R enclosure. Power distribution equipment. Outdoor breaker panels and disconnect switches rely on NEMA 3R protection to prevent rain intrusion while still allowing ventilations. HVAC systems. Rooftop HVAC control panels frequently use NEMA 3R enclosures to protect control circuits from the weather. Construction sites. Temporary power distribution boxes, often called spider boxes, use NEMA 3R enclosures because they are durable and weather resistant. Telecommunication cabinets. Roadside telecom infrastructures may also use NEMA 3R enclosures for rain protection. Field modification and enclosure integrity. There are situations where engineers or electrical designers request custom modifications to a NEMA 3R enclosure. When modifications are required, the best practice is to have the manufacturer perform the alterations. Field fabrications, such as drilling holes or cutting openings on site, is generally discouraged. Cutting holes in the field can void the UL listing, compromise the NEMA rating, and expose raw metal edges to corrosion. When a power-coated or galvanized enclosure is drilled in the field, the protective coating is damaged. The exposed metal becomes vulnerable to rust and corrosion, which can significantly reduce the lifespan of the enclosure. The number one reason why inspections fail, or the most common reason a NEMA 3R enclosure failed inspection, is the installation of unlisted connectors and fittings. The common violation includes a standard EMT compression connector with an O-ring, a PVC connector used on the top entrance of an enclosure that has uninsulated live parts and energized parts such as overcurrent protection, live bus, and live parts and conductors. The problem is it's not rain tight, not listed for a wet location, and does not maintain the NEMA 3R rating. That is the problem with having an unlisted connector on top of a NEMA 3R enclosure. The next violation includes improper conduit fittings. Examples include a set screw type of connector. Also, as mentioned, the compression connectors are not listed as rain tight. The next violation, unused openings left unsealed. Most contractors believe that the unused knockouts must be sealed with an approved closure plug. But here's the problem. The problem is you need to check with your authority having jurisdiction, because unused openings requiring KO enclosures could possibly void the listing of the NEMA 3R enclosure if located above the uninsulated energized parts. The only listed connector for a top entry above uninsulated energized parts is a UL listed connector, watertight hub called a Myers hub, used for top entrance above live and uninsulated parts, and is rated for the environment, such as a NEMA type 3R, a NEMA 4, or a NEMA 4X for wet locations. The National Electrical Code, Article 312.2, requires these fittings to be maintained to maintain the enclosure's integrity, often requiring sealing lock nuts to prevent water from reaching live components. A Meyer hub is designed to thread directly into the enclosure, provide a rain-tight seal, and maintain the NEMA 3R rating. Securely connect rigid metal conduits or IMC conduit. A standard connector cannot maintain the waterproof rating when installed above energized components. Inspectors often write corrections such as NEMA 3 enclosures, unlisted connectors installed above service entrance overcurrent devices. The only listed connector permitted in these locations is a Myers hub. Use only fittings listed for a watertight or outdoor location. Remember, the location constraints avoids you entering the top of the enclosure without a Myers hub. When possible, top entry increases the risk of water dripping onto energized parts. Avoid entering the enclosure through the top surface whenever possible. If side entrance is required, install the conduit below the lowest uninsulated live part. Also, seal all openings. All sides and bottom entry must be sealed with weatherproof gaskets, approved sealing compounds. Remember that a NEMA 3R enclosure sheds water but are not fully waterproof. Now, grounding and bonding requirements. Proper grounding and bonding of metal enclosures is essential. Relevant National Electrical Code articles includes 250.96 bonding of metal enclosures, 250.148 equipment grounding conductors. Also, key National Electrical Code articles for this topic includes Article 110.3b, follow the listing and labeling instructions. Article 110.11, protection from deteriorating agents. Article 300.6, protection against corrosion. Article 300.9, raceways in wet locations. And Article 300.15, boxes and fittings. Also, Article 312.2a, cabinets in damp or wet locations. What electrical inspectors look for when inspectors arrive on site. We typically check for the listed fitting, the waterproof connectors, the correct conduit type, grounding and bonding, unused openings and sealants, and proper conductor locations. Entries. The good news is that most inspection failures are simple corrections. Tips to pass inspections the first time. One of the things you need to understand is the term above energized equipment. The phrase above energized parts refer to the vertical location of a conduit entry relative to the live electrical components inside the enclosure. In a NEMA 3R enclosure, the design intent is to prevent water from entering the enclosure and contacting energized parts. For that reason, conduit entries are generally located at the bottom of the enclosure whenever possible. However, some installations require conduit entrance through the top or the side of the enclosure. When a penetration occurs above energized components, the fittings used must be specifically designed and listed to maintain the enclosure's waterproof integrity. For this reason, top penetrations are typically permitted only when a listed meter hub, commonly called a Myers hub, is installed. These hubs provide a threaded, weather-tight connection between the conduit and the enclosure, preventing water intrusions. The next tip to pass your inspection the first time is to know the acceptable locations for the Meyer hub installation. When listed for the application, the Meyer hubs may be installed in several locations on a NEMA 3R enclosure to maintain proper sealing and protection. The top of the enclosure, the Meyer hubs are commonly installed at the top of the meter enclosure or the NEMA 3R enclosure service equipment when conduits must enter from above. The hub maintains the watertight seal required to preserve the NEMA 3R rating. The bottom of the enclosure, the bottom entry, is typically preferred for most installation because it's naturally minimizes the risk of water intrusions. So the bottom entries are commonly used for incoming power conductors, grounding and bonding conductors, and feeder conduits. The lower side of the enclosure, the side entries, may also be acceptable when positioned below the lowest energized component within the enclosure. This placement reduces the likelihood that the water could drip directly onto the energized parts. Tip 3, to pass the inspection the first time. If you have a modification and listing integrity of all NEMA 3 enclosures. All NEMA 3 enclosures must be installed in accordance with their listing and manufacturer's instructions. Altering the enclosure in any way that were not evaluated during the testing may void the listing and compromise the weatherproof rating. Examples of problematic modification include drilling additional conduit openings in the field, adding a generator inlet port not evaluated for NEMA 3R enclosures, installing non-listed fittings or connectors. I mentioned the above incidents because in some field situations, some electrical contractors have modified enclosures, such as adding a generator inlet connector on the top of the NEMA 3R enclosure without the manufacturer's approval. These modifications did violate the enclosure, the NEMA 3R enclosure certification, and it led to code violation and inspection failure. Whenever modifications are required, they should be approved by the manufacturer or provided as factory installed options to maintain the enclosure's listing. Next tip, tip 4, use gasket fittings. Standard gasket fittings are generally not intended to replace listed hubs in a NEMA 3R enclosure. A Myers hub is specifically designed and tested to maintain the enclosure's weatherproof rating and typically includes a threaded body, an internal sealing surface, a weatherproof gasket, and a lock nut or threaded engagement with the enclosure. Other fittings that rely solely on external gaskets may not provide the same level of sealing required for penetration above energized parts. For any alternative fittings or unusual installation conditions, installers should consult the manufacturer installation instructions for any alternative fittings or unusual installation conditions. Installers should consult the manufacturer's installation instructions and wiring diagrams to confirm that the fitting is approved for use with that enclosure. The final tip to pass the first time is if you must enter the rear backside of a NEMA 3R panel, if inserting in certain installations, a NEMA 3R enclosure may feed directly into a building through the back side or the rear side of the enclosure. When a rear penetrations are required, only listed fittings such as a Meyer hub should be used where required by the manufacturer. It's required by the manufacturer. The enclosures should be mounted on strut, standoffs, or spacers to provide significant clearance for the hub and conduit connections. Mounting the enclosure directly against the wall without clearance can prevent proper installation of the hub, compromise the ceiling, and make future maintenance difficulty and affect the bending radius for the conductors. Providing adequate clearance ensures that the weatherproof integrity of the enclosure is maintained. My final thoughts. The NEMA 3R enclosures are widely used because they provide reliable outdoor protection at a reasonable cost. However, the effectiveness of that protection depends entirely on proper installation practices. The violations discussed tonight are common and preventable. Failure to correct these issues can result in reinspection fees, project delays, and additional enforcement actions. Inspectors are not here to stop projects. We are partners in ensuring life safety, code compliances, and long-term system integrity. When installations are planned properly, coordinated with the authority having jurisdiction, and installed according to the manufacturer's instructions and the National Electrical Code, inspections are generally quick and routine. Join me on Wednesday, March the 25th for another informative episode where we will review safety procedures outlined in the National Electrical Code and discuss common mistakes that occur during electrical inspections. If you would like to expand your knowledge of the electrical standards and best practices, you can explore the 60 Best Electrical Podcasts available online. Feel free to reach out through social media with any topic ideas. You can find me on Facebook, Instagram, and YouTube under the name Ask the Lady Electrical Inspector. You can also email me at asktheladyelectricalinspector@gmail.com. Thank you for tuning in. Until next time, stay compliant, stay safe, and keep the power flowing. Good night.